right, so we're going to create some linear systems today. Okay, so a linear system is, so we know what linear is. That's a straight line graph, right? So that's going to result in a straight line. We can also have it in the form, usually the equation, like those would be the y equals mx plus b, or the y minus y1 equals m times x minus x1. So that's all the stuff we've been working on. And a system is we're going to create two equations. So that's what the system part of it is. We're going to create the two equations to make up the system. So if you have two variables, you're going to have two equations. If you have three variables, you're going to have three equations. Four variables, we're going to stick in the world of two variables. And so our variables, like in these equations, would be the y and the x. The m is our slope and the b is the y-intercept. Okay, so that's exciting. So what we're going to do is the whole purpose of today is we're going to be creating the equations. And today we're just going to verify if the answers are correct or not. Then tomorrow we're going to do a quiz. Thursday, we're going to solve the systems by graphing them. We'll talk a little bit more about that. And then we're going to solve them by using algebraic methods as well. Okay, so a school bus that carries 12 passengers. So we have, you're going to need one of these, Escher. So there's a school bus company that has buses that carry 12 passengers and buses that carry 24 passengers. The total capacity is 780 people that they can transport. There are 20 more small buses than large buses. How many buses of each capacity does the school district own? Got it? Easy, right? So we've got an equation about passengers, and usually they're broken down into sentences when you're doing systems. Like, so one equation will be related to this information, and it's not always this way, but that's usually the way it goes. And then we've got this, there are 20 more small buses than large buses. So those two different pieces of information are going to be my two different equations. So my goal is to create two equations based on the information given here. Okay, so let's look at the yellow highlighted stuff first. First of all, let's define our variables. So we're going to identify the unknown quantity. So step one, identify. So this is going to be name your variables. So what are the two things I'm trying to find? I'm trying to find out how many buses of each type I have, right? That's the whole purpose of this question. So I'm going to say S equals the number of small buses, and L equals the number of large buses. So there we go. We defined our two variables. And so that's step one. So we got to name our variables. What do they actually represent? Probably zoom in a little bit here.
So I think that the variables explain like this certain the number of buses in total. So SL would be the total number of buses.
That's good, but we have some information that we're going to create our equations off of. Like, that's what we want in the end. We want to know how many buses of each we have, but we don't know how many buses we have in total. It doesn't say we have 40 buses in total. It tells us something about the passengers. So let's do our passenger equation first. Let's start there. So let's talk about the yellow stuff. Okay, so we know small buses can hold 12 passengers. So if I had 3 small buses, how many people could I transport?
36.
36. And how'd you do that math, Rahat?
My grandmother forced me to memorize the grandparents of the 20.
Perfect. I appreciate your grandmother. But the key thing is you multiplied them, right?
Yes.
Okay. So we're going to take the number of people per bus, and we're going to times it by what kind of bus you're on, or how many of the buses that we have. So we know 12 people can fit on each small bus, and we know that 24 people can fit on each large bus. And how many people in total can we transport? No, it says it's highlighted in the yellow. 780 people I can move. Okay, so that's my equation 1. That's the yellow. So the yellow one is all about the passengers. The yellow one talks about all about the passengers. Now when we go into the second equation, this is my orange stuff. There are 20 more small buses than large. So who's got more buses, small or large?
Small.
Small. So we know that the small, if I add, nope. So the small, the number of small buses is equal to the large buses plus 20. Isn't that weird that the 20 didn't go with the small?
No.
But small plus 20 equals L. That would mean however many small plus another 20 equals the number of large buses. But you guys told me the small buses were more. So that's incorrect. That one's wrong.
Yeah.
Yeah? Okay, so you have created a system. There you go. Well, we created it together. So these two equations form a system of linear equations, so two variables. You can use these two equations to solve for both the unknown variables. We're going to do that next week. We're not there yet. Okay, so now I'm going to get you to verify if the information I've given you is correct. Suppose you were told that there are 35 small buses and 15 large buses. Verify that this is the correct solution. So we're going to, by verifying, it just means to put it into the equations that we made. So equation 1 was 12s plus 24l equals 780. Right? Yes? Got that? And this is the information that was given. So we'd have 12 times 35 plus 24 times 15 should equal 780. So 12 times 35 is 420 people. And then 24 times 15 is 360. So 420 plus 360 is 780 equals 780. Is that a true statement? Yes, that's a true statement. So that works here, and we're going to check it in our second equation. So the second equation said S equals L plus 20. Oh, sorry, I'm kind of squished off to the side here. So we're going to fill in the information that we have. We have 35 equals 15 plus 20. So 35 equals 35. Is that true? Yes. So is this a correct solution? Yes, it is, because it works in both places. This is hard because you have to create the equations. That's the tough part of it. The math isn't hard on this unit, it's creating the equations. Sometimes I'm nice and I give them to you. This is your last unit. No one is panicking. A work period, yeah? Well, we've already started the video, so I can't stop it.
Quiz.
Your quiz is going to be a little bit longer, bud. Yeah.
How would those go? And
Dion. Did you like that? That was like a little bit French there.
you know how, like, you see how, like, when I was
Okay.
young, like, pasta
All right. So, two pieces of information. The perimeter of the Nunavut flag is 16 feet. And the length is 2 feet longer than its width. So we have two different sets of information to create our two different equations. And like I said, usually they're separated by a sentence. That's not always true, but sometimes, most times it is. So let's create our first equation. How do we find the perimeter of a rectangle? Add up all the sides. But let's talk about a rectangle. What makes a rectangle special? It definitely has four sides. No, it's not a square. It's a rectangle. So, would you guys agree that this side and this side will be the same length?
Yes.
And this side and this side will be the same length? Okay, so the formula for perimeter, and you guys have these handy dandy formula sheets, the yellow ones that I gave you. This is on there. So the perimeter formula of a rectangle is the perimeter is equal to 2 times the length plus 2 times the width. But we know what perimeter is, and the perimeter was 16. What didn't I do first? I jumped right into the equations. What didn't I do?
Identify the unknown variable.
I didn't identify the unknown variables. So what is L going to represent? The length of the rectangle? And W? The width of the rectangle. How many countries have a square flag? I know one for sure. I feel like there's two. What? You just don't know these fun facts right off the top of your head?
The actual answer is F. You could use F as a variable to represent the number of countries that have square flags, since we are uncertain of the number.
We could, or we could just Google it.
That's what I'm doing. There's two.
There's two. One Switzerland.
Switzerland and the Vatican City.
Oh, so Vatican City is where the Pope lives, and it's inside of Rome.
And then there's this weird one.
What is that?
Singapore.
Nepal. Nepal?
Nepal. I was like, I don't think Nepal has its own flag. Okay, so now we're a little bit richer of knowledge. I knew Switzerland was one, but I didn't know. I knew there was another one. Okay, let's go to the orange stuff. The length is 2 feet longer than the width. So what's longer, length or width? Length is the longer one. So we're going to add that 2 feet. So the length is the longer one, so that's going to be the width plus 2 feet. So that's my second equation. Ooh, and if it was a square, it'd be different. It'd be different. It'd be so exciting. Okay. Denise has determined that the Nunavut flag is 5 feet long by 3 feet wide. So now we're going to verify if that's correct. So we're going to put it into equation 1. 16 equals 2L plus 2W. So 16 equals 2 times 5 plus 2 times 3. Does it work here? Yeah, they're both equal to each other, so that makes sense. When wouldn't it work?
If you had a 4 instead of a 5.
Exactly. Like if we had 15 equals 16, that would be wrong. So we're going to check it in the second equation, which is L equals W plus 2. So the length is 5 equals 3 plus 2. Is that a good solution?
Yes.
Yes. So that works. Okay. Now you guys try.
What?
I did too. You guys can try this one. Okay, I will tell you that the sentences don't work in this one. You're going to create a money equation and you're going to create a quantity equation. So this one, the sentences don't work. My little trick for sentences just falls apart on the one I'm letting you guys do. Thank you.
Oh, Miss Darling, you're so sneaky.
Why, thank you. I do my best.
This new unit is like so confusing.
Okay, what were your letters?
P and B?
P and B. What did P stand for, Rahat?
P stands for pop can.
What about the pop cans?
P5.
No. What about, it has to be the number of pop cans, and it has to be the number of plastic bottles, right?
Yeah.
So that's really important that you're not just saying P represents pop cans, like what is it about the pop cans that it's representing? And it should represent the number of it. So this is what I got. So my first piece of information was about the quantity of them. They said that they collected 3,000 items for recycling. So the number of pop cans plus the number of pop bottles should equal 3,000. That's a lot of pop cans and pop bottles when you think about it. And then the next equation was about how much money they raised. So I made 5 cents on a pop can. So if I found 10 pop cans, that's going to be 50 cents. So I knew I had to multiply them again. And then 20 cents for a plastic bottle. So 20 cents times by however many plastic bottles I have. And I know the total of that is $195. So that one was a little bit different because the sentences didn't break it down into 2 nice sections for you. We've got more pages to do.
And could we try the next one too? Please.
So today we're just checking to see if this works and creating the linear system. Okay, so we've got to fill this in for the information. So equation 1 was P plus B equals 3,000. And it said 2,700 cans. So 2,700 pop cans plus 300 large bottles gives me 3,000. And that's good. Now we're going to check it into our second equation, which is a little bit more mathematical. So I would have 195. Whoa, okay.
Oh,
I just added 2 numbers together.
okay.
That's all I did on that one. So I'm substituting the information given just to verify that this is correct. So now I'm going to substitute in the information that I got. that it said I had 2,700 pop cans and 300 large plastic bottles. It's really fuzzy when I put it on the edge. So that one works, that one works. So that is a possible answer. Then the solution I gave, not good. You'd say no, that's not a correct solution. So that's only for today's lesson. Like, this is kind of like the baby steps, and then we're going to be solving these ourselves.
This is a baby step.
This is the baby step. Well, it's a tough baby step because you got to learn how to create the equations. Stepping can be pretty hard.
Miss Hannah, normally the first one is so much fun and easy, but this is so hard.
Okay. All right, guys, you're on to the next one. Do the next one, please and thank you. Attempt creating the system. It's really easy when I do it. It's harder when you have to do it on your own. Don't forget to define your variables. This one's similar to the bus one. This one's similar to the number of people on the bus.
Karen, how do you understand so much math?
I do it all day, every day. It's a very exciting life I lead. Try not to be jealous.
No, but like action.
Systems are super handy. You're going to use them a lot. I can't believe we're almost done May. Can't believe it's almost over. Do you guys want to see what I got? Or are you still working?
Show me how stupid I am. Oh. What?
So 8 packs of batteries and 4 packs of batteries. I'm sure you've seen them all in the store, right? Like, some contain four batteries in them, some contain 8 batteries in them. And it says the total number of batteries were 320. So it's not about how many packages they had of each, it's the total number of batteries. So my first equation dealt with that. So if I have 2 8-packs, that means I have 16 batteries. So it had to be the number of 8 packs times by 8, and the number of 4 packs times by 4. And it's going to give me 320 batteries. So that's what it was like the bus question there, because it was about the people on the buses. Now, the next part was a little bit tricky, but it's kind of like doing the opposite. There's 1.5 times as many 4 battery packs as 8 packs of batteries. So which one has more? The 4-packs or the 8-packs?
4 packs.
So I'm going to have to take my 8-packs and times them by 1.5 because it says right there, 1.5 times. It even told me the multiplication. I have to multiply. So that one's a little bit different. Am I good to flip the page? You fixing? Is that it? Is that all? Whoa. Why do I have 2 blank pages then? Oh, because I printed single sides. Okay, and your assignment is attached. I go from 1, 2, 3, and then to number 10. That's good. Okay, good luck with that.
I'm gonna need this. John said he's on his way.
Oh, good.